In this lesson, I'll show you how to calculate the volume and surface area of a cone. I've prepared for you two questions shown on your screen, but before we answer, let's discuss types of formulas we'll be using. For a right circular cone with height h and base r, shown on your screen, finding the volume can be done using this formula, and the surface area using this formula. With that being said, in question number 1, what are the volume and surface area of a cone with a height of 10 meters and a base radius of 8 meters? So in this particular case, we have a cone, and I'll show you how to draw a cone. First of all, draw an oval, then two lines with a common vertex. This should give you a good visual. So, our base radius is 8 meters. That's a distance from here to here. And the height of this cone is 10 meters. Now, in some questions, you may be given the slant height. So this is the actual height, that's the distance from here to here. But the slant height, in some questions you might be given, is the distance from here to here. In that case, you would have to use the Pythagorean theorem to derive the actual height. So to calculate the volume, and I'll label this as 10 and this as 8, we'll begin with the volume formula. We have a third pi times the radius, which is 8 to the power of 2, times the actual height, which is 10. Now notice something special here, that the formula without the third at the beginning is the formula for the volume of a cylinder. This means that 3 cones fit in the same space as one cylinder of the same height and radius. It's very interesting. So we'll use our calculator. We'll type in 1/3 by placing the third in parentheses, just like this. Then, rather than using 3.14, which is an approximation, most scientific calculators actually have a button dedicated for pi. It's now on the screen, times 8 to the power of 2 times 10. So the volume of this particular cone is approximately 670 meters cubed. To find the surface area, we use this more complicated looking formula. So I'll write down S is equal to pi times the radius, which is 8, times the square root of 8 raised to the power of 2, the radius squared, plus the height squared. So again, using our calculator, we have pi times 8 times the square root of 8 squared plus 10 squared. We end up with approximately 321. 321. And I'll ignore the decimal places just for simplicity's sake. Surface area is the area, so the units are squared. We have meters squared. Now let's move on to a real-life example. The question reads, many northern states stockpile salt to use for melting road ice. In one such state, the highway department builds sheds in a shape of a right circular cone to store the salt. Current sheds have a diameter of 30 feet and a height of 10 feet. The department plans to build larger conical sheds to hold more salt. The larger shed will either have a 10-foot longer diameter and the same height, or the other version is that you'll have the same diameter and a 10-foot greater height. We have to calculate the volume for each of the proposed sheds. We have volume is equal to a third pi r squared times h. We'll find out version 1 and version 2. So in version 1, that's when the diameter increases by 10 feet. The diameter and the radius are related in the sense that the radius is half the diameter. Originally, the diameter is 30, so if we're adding 10 feet to that, the diameter is now 40. We divide that by 2, so the radius is 20. And originally, the question gives us a height of 10 feet. So that's 20, and that's 10. Using this formula, we have 1/3 pi times 20 raised to the power of 2 times 10. Now let's set up the formula for version 2. We have a radius that remains consistent at 15 because the diameter hasn't changed, diameter being 30, and the height this time is increasing from 10 to 20. So plugging that into the formula, we have 1/3 pi times 15 raised to the power of 2 times 20. Now let's use our calculator really quickly for both of these. We have 1/3 times pi times 20 to the power of 2 times 10. So for the version where the diameter increases, we get a volume of 4,188. So that's the approximate volume, and that's in foot cubed. All we have to do now is just change this 20 into 15 and this 10 into 20. And this gives us a volume of 4,712. Approximately that. Cubic feet. As you can tell, it's probably better to increase the height to 20 as opposed to increase the diameter 10 more. In the second part of this question, calculate the surface area for each of the proposed sheds. So again, we'll be doing the exact same thing except for calculating the surface area this time. So I'll place this on the side. And to calculate the surface area, again, that formula is S is equal to pi r, the square root of r squared plus h squared. Let's write down version 1 and version 2. Beginning with version 1, pi times 20 times the square root of 20 squared plus 10 squared. And for this one, pi times 15, the square root of 15 squared plus 20 squared. If you calculate this, let's use our calculator. Pi times 20 times the square root of 20 squared plus 10 squared. We get a surface area of 1,404 square feet. And for this, we'll modify our equation a little bit. So the radius is 15 and the height is 20. We get 1,178. Now let's discuss which one is more economical. Version 2 obviously has more volume, so it wins on that behalf. Version 2 also uses less material because it has less surface area. And when you're building something, of course, you want to save on cost. So in this case, it would be better to go with 1,178 over 1,400, which means more material cost. The better version, therefore, is version 2. Now, of course, you can make different arguments and say that it's better for it to be wider so that things can go in and out more easily. But for the sake of simplicity, we'll just say that version 2 will help save us on cost. And there you have it. That is how to calculate the volume and surface area of a cone. If you have any questions, please use the comment section underneath or our website where we can gladly assist you further. Talk to you later.